Today we're going to start our chapter 2, our unit 2, which is on rational and irrational numbers. And apparently I have forgotten how to talk or to write, so rational and irrational numbers. Please have your pencil and notebook out so that you can take notes, and feel free to pause the video to catch up whenever you need to. Unfortunately, this lesson probably has the most notes you are going to take, but it's going to get easier after this. So why don't we get started? So we're going to talk about different kinds of numbers, and the biggest set of numbers we have is rational numbers. It's any real number that can be written as a ratio of two numbers. So anything that can be written as a fraction, like 1/2, 1 3/4. We can change that into an improper fraction. It can be written as a fraction. 6 can be written as a fraction. All we have to do is put it over 1. -2 can be written as a fraction, and we just have to put it over 1. Rational numbers in decimal form are terminating, meaning they're going to end, or repeating. And we're going to talk about more of that a little bit later, but have both of those in your notes. Next one we're going to talk about is an integer. A real number that only has the value of 0 for its decimal places. So 1 1/3 is not an integer. 1 is an integer. 0 is an integer. -5 is an integer. 523 is an integer. -478 is an integer. Nothing after the decimal point. That's where 0 comes in for its decimal places. It can be positive or negative whole numbers and their opposites. The next one we're going to talk about is a whole number. Real numbers that include all positive numbers. Oops, sorry, let me go the other way. That includes 0 and all positive numbers. So 0, 1, 2, 3, 4, 5, all the way up to whenever. Those are whole numbers. Remember, feel free to pause the video anytime you need to catch up. Natural numbers are real numbers that include all positives, but not 0. We start with 1. The easiest way to explain this is when you were younger and you were learning how to count, you did not start with 0, you started with 1. Anything bigger than 1 is a natural number. The last number we're going to talk about is an irrational number. And again, we're going to come back to this a little bit later, but an irrational number is any real numbers that cannot be written as a ratio of two integers. Irrational numbers in decimal form are non-terminating and non-repeating. The most popular irrational number is pi, 3.14, and then it just keeps on going. It never ends, and it never repeats. That is the most popular or most well-known irrational number. Again, feel free to pause the video and catch up on the notes. So one way to organize it is in this grid, so to speak. So we talked about rational numbers: 2 1/2, 1/3, 25 hundredths, 1 5/10, -4, -10, 0. Anything that can be written as a fraction. Then we talked about integers where it had 0 for the decimal places. So we could have negative numbers, negative 10, negative 75. We could have 0, and we could have all the positive numbers. Those are integers. Whole numbers start at 0 and go 1 all the way up to whatever. Natural numbers does not include 0. It starts at 1 and goes on up. Irrational numbers, I think we had pi in here. And like I said, we will get further into different irrational numbers later on in the lesson. So let's see if we can figure this out. I want you to take a moment, pause the video. I want you to tell me if each number is rational or irrational and why. So pause the video and see if you can tell. So let's go through 12.452. This is rational because it is a terminating decimal. We can put 12 and then 452 thousandths into a decimal. Pi is irrational. It is non-terminating and non-repeating. Next one, negative 3.151515. This is rational because it is a repeating decimal. And the last one, 2.45761239. This is irrational because it is non-terminating and non-repeating. And the last one, negative 3.5. This is a rational number because we can write it as a fraction. Next, we're going to convert fractions into decimals, and this should be something you guys have done before. To do it, all you're going to do is divide the numerator by the denominator. So here we would do 2 divided by 5, and we would get 4/10. For letter B, we would do 2 divided by 3, and we would get 6/10 repeating. So we're going to put the bar across the top. When we get numbers that have negatives, we just put the negative sign in front of our decimal. So for this one, we're going to do 3 divided by 8, and we would get 3.375, and then we're just going to put that negative in front of the decimal. Same thing with whole numbers. Let's do the fraction. 1 divided by 5 gives us 2/10, and all we're going to do is put that 2 in front. So we get 2 and 2/10. Same thing here. We're going to put the 3 out front. Do the fraction. 2 divided by 3 gives us our 6/10 repeating, and we just put the 3 in front. Even with negatives, 3 divided by 8 gives us that 0.375, and we put the negative 7 in front. So here's where we're going to talk about the repeating and terminating decimals. And again, pause the video so you can write things down if you need to. Repeating decimals are any decimals in which the digit or group of digit repeats forever. Examples, 3/10, 1/3. If our fraction is 1/3, it comes out to 3/10, 0.3333333, or we can write it as 3/10 repeating. It could repeat two numbers, 1 5 1 5 1 5, and just keep on going. It could be repeating 3 numbers or 4 numbers. A terminating decimal ends. That's the big thing. It ends. 1/2, 5/10, 25 hundredths, 75 hundredths, 4/10. Those are ones that just end. They do not go on. Those are terminating decimals. So the biggest thing that you have to do with these is compare them. So we're going to use either greater than, less than, or equal to. When you're comparing decimals, you compare the same number of places after the decimal. 3/10 and 4/10. 4 is bigger than 3, so 3/10 is less than 4/10. The next one, we have 3/10 and we have 28/100. If we put them one on top of each other, make them the same number of decimal points. 30 is bigger than 28, so 3/10 is greater than 28/100. It works with repeating decimals as well. 0.333, and notice that it keeps on going versus just 3/10. If we just add the zeros, and now you look at them, the 333 would be larger than the 300. So 1/3, 3/10 repeating is greater than just plain 3/10. However, here, I'm going to put this one above. Now we have 4/10, but 400 is greater than that. So 3/10 repeating is less than 4/10. Negatives, be careful with these. They are just the opposite. Here we had the same numbers, but now we have the negatives in front of them. So remember, it's the one that's closer to 0, which is the bigger number. So here, this is the one that's closer to 0, so that is the bigger number. Same thing with letter D. It's the same as D. The second D here is. Now instead of 4/10 being larger, the 3/10 repeating is actually closer to 0, so it is greater than. Letter E should be fairly easy. We are comparing a positive number and a negative number. The positive number is always bigger than the negative number. The last one, I would recommend changing your decimals into fractions into decimals, So I would do 3 divided by 7, which would give me a negative 0.4285, and it would keep on going. 4/5, so 4 divided by 5 is 8/10, but that's negative. This is the one that is closer to 0, so that is the bigger decimal. Hang in there, guys. We're almost done. You can also put numbers in order from least to greatest. First of all, here's what I would say to do. Convert all fractions into decimals. It's easier to compare decimals. So I have negative 5/10, 1 25/100. Negative 1/3, I'm going to change this into negative 3/10 repeating. I got a positive 5/10 and negative 5/3. That is a negative 1 6/10 repeating. So there's step 1. I put them all into decimals. If you need to, sketch a number line. Some of you do a really good job when you have a number line that you can put them on. Order all the negatives first, and then all the positives next, and then finally rewrite them in their original form. So here's my number line. I'm going to put 0. We'll just go up a little bit, quick and ugly number line. 1, 2, 3, negative 1, negative 2, negative 3. So here we go. Negative 1/2. Negative is down here, so that would be negative 1/2. My other negative is negative 3/10 repeating, so that's like 1/3, so that'd be like right here. Negative 3/10 repeating. Negative 1 6/10, or 6/10 repeating, so that would be down here. Negative 1 6/10 repeating. Now I'm going to do my positive numbers. 1 25/100 would be about right there. And 1/2 would be right there. So now I'm going to put them in order with their original form. So negative 1 6/10 came first, and we said that was negative 5/3. Negative half, that was the way it was, so negative half. Got that one. Negative 3/10. That's our negative 1/3, so I would write negative 1/3. 1/2 stayed the same. And 1 and 25/100 also stayed the same. So there is my answer in the original form. Last thing we're going to talk about is squares and square roots. So if I'm going to square a number, that basically is 3 squared is 9. So that means 3 times 3 equals 9. But we're also going to go the opposite. The square root of 9 is 3. It's basically asking what number times itself equals 9. So the best way to really go through these is just to do a bunch of examples. So here we go. Let's do a bunch of examples. Letter A, what number times itself equals 4? That would be 2. Anytime you think you get this, stop the video, pause the video, and do them on your own and see what you get. So let's do letter B. What number times itself equals 25? That would be 5. What number times itself equals 49? That would be 7. What number times itself equals 16? That would be 4. What number times itself equals 81? That would be 9. What number times itself equals 64? That would be 8. The next couple are a little bit trickier because they are larger. Most of the time when I give you ones, I'm going to keep it smaller. But what number times itself equals 256? That is 16. And what number times itself equals 441? That would be 21. The next two are harder because they don't work. Let's take a look at these. Is there a number times itself that equals 2? We can do 1 times 2, but 1 times 1 does not work. 2 times 2 does not work. So there is nothing. There's nothing that the number by times itself works. So this is an irrational number. Same thing with 5. What number times itself equals 5? There is nothing. So this one is also irrational. Feel free to go back through the video at any point in time to review something because your homework is in Go Formative. You are going to do the 2.1 worksheet in Go Formative. It's only 17 questions, but feel free to review this video. I know it's longer. I know there's a lot of notes, but you guys can do it. This is your only assignment for Monday and Tuesday. Good luck.